Like I think like sometimes I thought that it's but I think actually right. So
We are going to start with very simple trigonometric equations, okay, like these ones. They are more like grade 10 trig equations. Now, last year, when you were solving for, for x or theta or alpha in this case, you were only solving for value of an angle between 0 and 90 degrees, okay? Because you were in grade 10. But going forward, as I said on Tuesday, all your trigonometric equations have got an infinite number of solutions. Okay? So during the course of my teaching, I'm going to connect you to both the trigonometric graphs and trig equations because there is a relationship. Okay, so we'll start with a simple one. Sine theta is equal to the square root of 2 over 2. Okay, so we are supposed to determine the general solution. Please be aware that we are not solving for theta. We are trying to find a formula or formulae that we can use to determine all the possible values of theta. There's a distinction there. So we are not finding a specific value or specific values of theta, but we are finding a formula that we can use to determine all the possible values of theta. So the general solution is a formula, okay? Or it's a set of formulas. So from here now, from Tuesday's lesson, this will become, because here our ratio is square root of 2 over 2, okay? And on the left-hand side, we have got sine theta. So this is already simplified. So theta will be equal to shift sine of the ratio, is shift sine of root 2 over 2. Then we add, now because this angle here is equal to 45 degrees. Okay, by the way, shift sine of root 2 over 2 is equal to 45 degrees. So 45 degrees will be our reference angle, but because the sine graph is periodic, okay, we can get many solutions. So this will be plus k times 360 degrees, because we can go clockwise or anti-clockwise to get many solutions, right? Where k is an integer, right? So the first general solution for sine will be theta will be equal to 45 degrees plus k times 360 degrees, where k is an integer. Okay, so this is the first general solution for that trigonometric equation. Now, if you remember well from Tuesday's lesson, I told you that this angle here is called the reference angle. It has got a sister or brother in the second part. Yes.
so you always have to write that k is
Yes. Yes. Generally, we give you a mark for knowing that k is an integer. Okay? We use k, but if you read some textbooks, they may also use n. Okay, but in my teaching, I'll use k. And k is the most common variable, or rather, letter which is used to represent the integers when you are dealing with the general solution. Okay? So always you have to write that k, this k here, is an integer. Okay, there is a mark allocated for that. Right, so this 45 degrees is our reference angle. Okay, it has got another angle which is in the second pattern, which is obtuse, which gives us the same solution or the same ratio if we put it where there is theta there. So this is our first general solution. Then the second one, we'll get it by subtracting the acute angle from 180 degrees. So the next one will be 180 minus 45 degrees plus k times 360, where k is an integer. So this will become 135 degrees plus k times 360, where k is an integer. Okay? So I've determined our two general solutions. This is the second one. Okay? Please be aware that sine has got two general solutions. Okay? So if we start substituting the values of k here, let's say we substitute k equal to 0, we'll get a solution which will be theta equal to 135 degrees. If we substitute k equal to 1, means the solution that we get for theta is 135 plus 360 degrees, which will give you almost like 495. If you substitute k equal to minus 1, you get another solution, and so on. So there are many solutions. Okay? Please be aware that this formula and this one here, they are called general solutions. Okay? They are just formulae that can help us to find all the possible solutions. Is that clear to everyone? Yes. So you don't need to find a specific value of theta when the question is asking for the general solution. Okay, so our two answers are this one here and this one here. Okay, those are our two solutions. Is that clear? Right? So let's move on to another one. Okay, let's do number 2. Number 2, we have got cosine of x is equal to 0.4. Okay, again, cos has got two general solutions. So this will be x equal to plus or minus shift cosine of 0.4 plus k times 360 degrees, where k is an integer. Okay? Then you need to take out your calculator there. What is shift cosine of 0.4 to two decimal places? So that will be 66.42 degrees plus k times 360 degrees, where k is an integer. Okay? Please be aware that from Tuesday's lesson, okay, this plus or minus here is an indicator that we have two general solutions there. Okay? So our reference angle here, okay, our reference angle can be either the positive 66.42 or the negative 66.42. Okay? Alright, so we have got two reference angles there. Okay, it has to do with the quadrants, right? If you remember well, on Tuesday I told you that sine, we know that sine is positive in the first and the what? Second quadrant, right? So if you get a reference angle which is positive and it's acute, you need to know that it has got a corresponding angle which is obtuse in the what? Second quadrant. That's also applicable to cos as well. Remember, cos is positive in what? First quadrant and the fourth quadrant. Alright? So if you look at these two angles here, positive 66.42 is in the first quadrant. Am I right? And in which quadrant is minus 66.42? Fourth. So we have got two general solutions to cater for the quadrants. Okay? Of course, tan is unique because if you go to the graph of the tan graph, okay, it has got a period of 180 degrees. So it only has one general solution. Because of the reflection, I think I explained this, right? If you start in the first quadrant for tan, if you add 180, you come to the third quadrant. Now, because tan is positive in the first and the third quadrant, there's a reflection there. In this case, the reflection will be about the line y equal to x. Don't go there, right? Let's not worry about that. All you just have to remember is that the tan graph is a period of 180 degrees. Therefore, we have got one general solution for tan. For sine and cos, we have got two each, because sine is positive first and second, and cos is positive first and fourth quadrant. Have I answered you? Okay. All right. Please be aware that there is no need to convert the negative 66,42 to a positive angle. There is no need for that. Because I know some of you might go for tuition and then for some teachers and tutors, they convert the negative 66,42 to a positive angle. That's not necessary. Okay? It's not necessary because you will be doing the same thing twice, but in a different way. Okay? All right. Any questions? Okay, let's do one for tan, number 3. So tan alpha is equal to 5 over 3. Okay? Tan alpha is equal to 5 over 3. So here, since this is tan, we only have one general solution, but we no longer have to add k plus 360 based on the graph of tan. Okay, the graph of tan is a periodic graph as well, so we add k times 180. So this will be shift tan of 5 over 3 plus k times 180 degrees, where k is an integer. Okay? Then, if you look at it here, you end up getting alpha equal to what? 40?
59,04.
59,04 degrees plus k times 180 degrees, where k is an integer. Okay? Right, I just want to show you something from the graph. Do you remember me telling you that, I'm not sure whether I told this class or the other classes, but there's an application called Geogebra. I'm not sure if you have ever heard of it.
Yes.
Right? It's a very nice application. It's free of charge. Okay? That application, at the moment, I don't know if there's any application which is as good as that, because I actually use it a lot, right? For sketching graphs, any graph, okay? You can sketch whether outbreak or trigonometric, and you can do a lot of playing around with it, but it requires you to be quite proficient with computers, and you have to learn as well. Okay, so this application here, it has got a graphing calculator, which you can use for drawing graphs. Also, yes, a geometry component where you can draw geometric diagrams and so on. It's free of charge, so you can download it online, either on your phone or your tablet or your laptop, and you can play around with it. Okay? So, I want to show you something. But if you draw trigonometric graphs, okay, at this stage, let's just talk about 0 to 3. Okay, not 0 to 3, 6. Let me have 3 revolutions. Okay? Maybe 4 on both. Then someone is talking. If I'm talking, you're supposed to be quiet. That's very basic. And in this class, I'm not even supposed to say it. All right? So let's say minus 720. Or rather, let me change the put the degrees first. Then what's left of trig after demonstration? It's quite a lot. You've got trigonometric graphs, then you've got area sine and cosine rule. It's quite a lot.
And we're doing trig graphs after this.
Yes, we should do trig graphs after everything.
Graphs. Graphs. Graphs.
Okay, let's have a distance of say 45 degrees. There is also another application which is called Desmos. Okay, Desmos. But Desmos is more like it's a web version now. You need an internet connection. The good thing about Geogebra is you can download it as an application. You don't need an internet connection. Like the one that I'm using, I downloaded onto my laptop. Okay, so I've got my degrees there. Then the next thing, well, I think I can just increase the font that those who might have challenges can see. Okay, I've increased the font. Then let me put my equation. Like I'm going to put, okay, let me just put the sine one. Okay, square root of 2 over 2. If you convert this to a decimal, what answer do you get? Square root of 2 over 2. Can you stop talking? Stop talking. Right. What I want you to be aware is that sine theta equals square root of 2 over 2. When you talk about the graph of sine, this square root of 2 over 2, it's a y value. You agree with me there? Okay, it's more like this. If I were to give you the basic sine graph, y equal to sine theta, okay? And then I say, okay, find all the possible values of theta when y is square root of 2 over 2. That's what this means. Okay? That's what this means. Hey, can you pay attention? Right? You need to be aware that your knowledge of trigonometric graphs and trig equations is very important. If you are to understand trig equations, you need to connect them with the graph. Okay? So that root 2 over 2 is a y value. Okay, so let's go to GeoGebra now. If I put my function, now when I put my function, I'm going to put it as y equal to sine theta. I can put it as f of x equal to sine theta. And I hope you remember from last year that f of x is the same as y. Okay? So here I can put it as y, but generally I prefer to use function notation. So this will be sine. Okay, let me just use the application itself. So if you are putting on GeoGebra, if you are putting a trigonometric function, you have to put the degree sign. Okay? That's how the application was programmed. Okay, but the good thing is on your graph you can edit that. But when you're putting, you have to do what I just did there. Okay, so we have got that. Right? Now, if I wanna add let me just make this a little bit larger. Okay. Okay, for now, because of time, let's just approximate to where 0.7 is. Okay, let's just approximate where 0.7 is. Okay, so if I go to the graph, 0.7 will be approximately, say, here. Let me just check this to my e-beam quickly. Right. So, if I want to find the values of theta, I have to go to my graph. Then I'll locate where 0.7 is. So this is 0.5, that is 0.6, 0.7, 0.8, 0.9. So 0.7 will be there, right? But I'm sure you can agree with me that that's not the only point where y is 0.7. Y is also 0.7 here, and y is also 0.7. Okay, I go down, so this is go to my left. It's also 0.7, those 3 points. Then there's also a point to the far right there, where it's also what? 0.7. Okay, and also here, 135 years. Okay, so it means that we have got 5 values, okay, according to this interval that I have here, that can satisfy this equation. Okay, sine theta equals square root of 2 over 2. So if you put the x values at any of these points, those x values, right? You put them in the calculator, those values, they will give you the same value, which is square root of 2 over 2. But we are only talking about, this is, if I'm not mistaken, this is 360 here. So minus 360 up to 405. So if we go beyond on either side, that is the negative side and the positive side, we will get more solutions. Okay? We'll get more solutions. Because of that, we can get an infinite number of solutions that can satisfy that trig equation. That's why we need a general formula, which is called the general solution, because there are many solutions. You understand the concept?
Yes.
So this is actually going to be helpful if you are doing trig equations. The knowledge of the trig graph and trig equations has to be integrated. All right? We can do the same for the graph of tan and the graph of, for the equations for cos and also sine. It will be exactly the same. The reason why is because the trigonometric graphs are periodic. They oscillate, they repeat themselves from negative infinity up to positive infinity. So we have a range of solutions that are infinite. All right? So, now let's move on to an exercise where we'll find specific solutions for a given interval now. Okay? Sometimes you can get a question